Good evening, boys. I hope it's all going well for you. And I say boys because look at this. It's a sausage fest in here. Anyway, I'm doing fine, thank you for asking. And as for Boomzerk Reloaded, it's going swimmingly. And there's a lot of things to talk about. So, without further ado, let's get into it. Starting with the easy stuff, while working on other systems, I have also improved the already existing ones to make the code more easily maintainable and slightly more performant. First things first, like I mentioned in the first video, the enemies now use direct spatial queries instead of relying on area 2D collisions. Enemies now also have a generic AI function that the enemy manager calls every few frames. Right now only the simple melee AI exists, but the system is pretty simple to expand. Speaking of melee, it's kind of a hack, since there is not a real melee system in the game. The enemies just spawn big bullets that don't move and last a single frame, as you can see here. Normally the bullets would be invisible, but I've made them visible for this segment of the video. Just, to show you how it works. It's a simple solution that entirely avoids the problem of creating a melee system from scratch by reusing an already existing system that already works pretty well. Since we are already on the topic, bullets also received some love. The code is now much more readable, it behaves in a much more predictable manner, and it is more performant, since every bullet now only stores a reference to the shooter damage instead of having its own unique damage object. This cuts down on memory usage and reference count by a lot. Also, bullets can now penetrate targets and grow or shrink while moving, which helps with a variety. I also plan on adding acceleration and deceleration, which should not be too hard with the current system. Since the game is a bullet heaven, it needs items that give you special abilities. Like for example an aura that hurts whoever gets too close. Guns also need to have some special effects as well, beyond basic damage and fire rate differences. Like for example creating a shockwave on reload or something like that. So, to fulfill this need, I came up with the Modifier system. It's basically a custom event system that allows me to modify the state of the game if specific events occur. A modifier, as you can see from the abstract parent class, is a very simple object. You have a few methods to retrieve metadata and a single method called effect that actually does stuff. I'm using getters for metadata since, as much as I like GDScript, it is not as complete of a language as something like Python, since you can't override parent constants in the children. And since we are on the topic, another thing in the current version of Godot, which is 4.7.1 as of the making of this video, is that nested typed collections are not supported, which means I can't do something like a dictionary containing arrays of strings. Instead, I have to define a dictionary that contains variant arrays, which is really annoying since it fucks with the typing system, and most importantly, it fucks with me, since I enjoy explicitly typing things wherever possible. Hopefully, these shortcomings will be fixed in the future. Anyway, back to the topic. These modifier objects are stored in dictionaries inside of moddable objects, using their triggers as keys in said dictionaries. Whenever a function is handling a moddable object, if necessary, the modifiers are retrieved and then iterated upon, one by one, changing the state of the involved objects. For example, here's the only modifier currently in the game, the test modifier. It prints the ammo left in the gun to the STD out and how many bullets the weapon shot so far whenever the gun shoots. It is not a particularly cool modifier, but it shows how easy it is to implement a modifier, and acts as a way to check that the system actually works. Note that this system is completely synchronous and does not use the built-in Godot signal system, because I need to control the order in which the modifiers are applied. Also, this system is slightly faster, which is a plus. Another cool thing to note is that modifiers are actually instantiated as nodes in the game scene, so they can have their own physics process function that does things. Like for example, heal you or shoot additional bullets or stuff like that. Damage is no longer just a simple value that equals how much damage a bullet does. The damage calculation got way more complex, as you can see. Maybe it's overkill, but we'll see about that. First of all, there are now a total of 5 types of damage that you can inflict. And of course, there are also 5 types of resistances to match. The damage calculation starts by duplicating the original damage object to avoid messing with it, since I use the same object to store damage values of entities and for calculations. I know it's not a great pattern to follow, but as long as I'm the only person working on this, it's probably gonna be fine, even if the API isn't exactly safe. Anyway, after duplicating the attacker's damage object, the pre-damage modifiers of both the attacker and the target are applied to the damage. Then, the target resistance is applied to the damage, and after that, the post-damage modifiers are applied. And finally, crit damage is calculated. As you can see, it's a multi-stage system that allows for a lot of flexibility. Speaking of flexibility, registering a new event is pretty easy. I just need to add it to this enum here and add handlers wherever needed. I'm also working on making effects proc on enemies or players when receiving too much of a specific elemental damage, like setting someone on fire when receiving too much fire damage, or stunning someone when receiving too much electric damage. But that's still an early work in progress, and I want to show it here. Finally, we get to the third pillar of the game, the guns. I'm happy to report I got the first version of the procedural gun generation working. Let me show you how it works. Gun generation is handled by the gun factory object, which is a singleton loaded at startup time. The main method of this object is buildGun, of course. BuildGun can generate guns based on the given gun type, gun level, gun rarity, and luck, which controls how biased your rolls are going to be during gun generation. First of all, the amount of points available to generate the gun is determined. Points are what my generation system is based on. They basically act like perk points in any RPG that are used to unlock or upgrade different weapon stats. We'll see how later. After the points calculation, the basic gun scene is instanced, and the base damage type or types of said gun is also chosen. Some guns can have multiple damage types, while others can only have one. For example, rifles and pistols can have 2 elemental types, physical, which is the default, and a random elemental type. Throwers, on the other hand, can only have 1 elemental type. Then, if the gun is uncommon or better, a modifier of the matching rarity is added to the gun. Right now, only the test modifier can be added, since, as I said before, there is only one in the game, and it's the test modifier. More will be added in the future, of course. Then, if you're lucky, the gun can be enhanced and spawn an additional random modifier. The gun can have more than one enhancement if you're extremely lucky. Then, we finally get to how the points we calculated before are spent. Basically, they are randomly divided between raw damage upgrades and weapon stat upgrades. Raw damage upgrades always cost a single point, while stat upgrades can have different costs depending on how strong or valuable the upgrade is. For example, a small recoil reduction only costs a single point, while a bullet penetration upgrade is extremely strong, so it costs 10 points. These values are not final, of course, they still have to be balanced. Finally, a name for the gun is generated by taking into account the gun type, the elemental damage types, and the modifiers applied to the gun. I'll also briefly show how the gun stats upgrades are handled, since it is an interesting system on its own. Basically, every stat upgrade is a small static class with just 2 methods, canApply and apply. The canApply method checks if the upgrade can be applied, of course. For example, by checking if the gun generator has enough points left and if the stat being applied isn't too high. The apply method is self-explanatory, I think. To make a stat upgradable in a gun, I just have to modify the getUpgrades method in each gun subclass to return an array with the available upgrades, which in turn are usually stored in a static array. The gun generation system is able to generate varied guns with wildly different stats. You're basically never going to see the same gun twice, once all the content is in the game. The cosmetic part of the gun generation hasn't been implemented yet, since I'm a bad artist, but it's going to be modular and have some visual variety as well, not just mechanical. The basic game systems are now in place, as you could see from the video. So now it's probably time to start turning this glorified tech demo into an actual game, as I have a lot of ideas for doing that. But for that specifically, you'll have to wait until the next video, since we're out of time for today. Like and subscribe if you enjoy my stuff, and hopefully I'll see you soon in the next video. Bye bye.